So let us take few more question and answer in data structure and algorithm. The first is define data type and abstract data type and comment upon the significance of both. So data type of a value or variable in some context is an attribute that tells what kind of data that value can have. For example, if I say int a, so a is going to store all the integer values. Float a will contain only the floating point values. So most often the term is used in connection with the static typing of variables in programming language like C, C++, Java and C Sharp, where the type of variable is known at the compile time. So integer, it stores the whole number and signed numbers. Floating real numbers, character stores a character, dollar can be a character. Boolean stores true and false, that is, it stores 0 or 1. What about abstract data type? Abstract data type is, you can say, it is a basic mathematical concept that defines the data type. It is the mathematical concept which defines the data type. So abstract data type tells about the operations which can be applied on the data type. So these operations, how to implement it is not given. It is not given. It is up to your discretion. So if I say that you have to make certain data structure in which input should be from one side, output should be from one side, or insertion should be one side, deletion should be one side. So this is the mathematical concept which has been applied or forced or imposed on a particular abstract data type. Now you want to do it using say array, it's up to you. You want to do it with linked list, it's up to you. But it should follow the mathematical concepts which has been, or the operation imposition that has been applied on it. Execute your algorithm to convert an infix expression to postfix expression. This is the expression for you. So let us see how it is going to be. I'll quickly summarize it. Whenever the token, let us tell them token. This as the operand, this is the operator. So whenever the token will come, we'll place it here. Whenever the operator will come, we'll place it here. Whenever a variable will come, we'll place it on the postfix notation. So we'll place on the stack the various tokens and the variables here. But there is a catch. And what is the catch? Catch is that whenever you are placing, say, round bracket, and any other thing is coming, any other token is coming, and whenever you have a closing match or closing round bracket, these two will be removed, and all those in between will be popped off and placed in front of or at the last of the variable. In a similar fashion, when you have a round bracket, a square bracket, and when you encounter in the stack square bracket which ends, you have ending square bracket, so all other will be popped. So same is happening here. First this will come, all this will come when A will go here, and all other things is happening. So I'm just okay. Now after B, AB is okay. After B, the closing round bracket has come. So as this closing round bracket has come, these two will be gone and plus will be placed here. Hope you got the idea. In a similar fashion, all these will be popped. Don't worry about this. But as soon as you have round bracket, but as soon as the closing round bracket will come, this one, as soon as this will come, this will be gone and plus will be popped here and placed in the last. Then all these values will be placed. Round bracket has come and we are waiting for the ending round bracket. So as soon as the round bracket will come, the ending round bracket, which is after F. So once F has come after round bracket, once the round bracket has come, this division will be placed here, and others, these two, will be popped. Okay. Then the square bracket has come. Of course, square bracket has ended here, so these two are going to come here. Similar fashion, all these will be placed on the stack, but G, H will be placed. Then plus has come, we'll place it here. But round bracket has come, round bracket has ended, plus will be placed here. And finally, because this is the first one, this is the second one. And you know that in plus and division, the precedence is division. So the final operation would be like this. Simply what we are placing it on the stack and just only removing them when you have a closing bracket or closing square bracket. Nothing else. Enumerate various operations possible on ordered list and arrays. Write procedure to insert and delete an element into an array. So an ordered element is a container which holds a sequence of objects. And each object has a unique position in this sequence, like an array. So in addition to the basic repertoire of operations supported by all searchable containers, orderlies provide the following operation. You can seek a position, go to a position, you can access a position, you can remove the object from the list, you can insert before, insert after, all this you can perform. this how you are going to insert an element, how you are going to delete. Let me give you an example. When you want to insert an element, say at this point, what you are going to do? These two numbers will remain here, and we have to shift these two. So we have to shift these two, this to this space, this to this space, and now we have a place. So we'll insert an element. So this is what here, same, the algorithm, the code is doing that. What about deleting? Now you want to delete an element. What you're going to do? Say you want to delete this. So there is no point in deleting. You just shift this value here, shift this value here. This value will be removed, or say superimposed by this value. So this is a deletion. By taking the example of how multi-dimensional array can be represented in one-dimensional array. So multi-dimensional is nothing but arrays of arrays. Even if you have array of this type, two-dimensional array, of array of three type, or for array of say 1, 2, 3, 4, 5 dimensions, it is stored in single list only. This is just for users, for us as an impression that how we are going to perceive the dimensional form. Otherwise, if you actually see 3, 4, 2, so this is a three-dimensional array. If these are the values, they will be from 1 to 8 are stored here. From 9 to 4, simply they are stored contiguously. And 6 to 23, see. So multi-dimensional arrays are just an abstraction for programmers, since we can obtain the same results with the simple array just by putting a factor between its indices. Show the various passes of bubble sort on an unsorted list. So let us see 11, 15, 2, 16, 2, 13, 6. So first of all, what you are going to do? You are going to compare with what? This is 2. And see, first you have to compare, say these two, or these two, or this is because the first pass is you want the highest element to be here. So first what is happening is 11 will be compared with 15, which is greater. 15 is greater, so it will not change the position. Then 15 will be compared, this is not 1, this is 2. 15 will be compared with 2, which is greater. 15. 2 is less, so we have to change the position of 2. 15 will go here. 15 will be compared with 13, which is greater. 15 is, of course. So 13 will be exchanged with 15. Which is greater? 15 or 6? Which is larger? 15. 6 will be shifted and 15 will find its position. So at the first pass, 15 has bubbled up from the second position to the last position, or this is the highest value. Now we'll not look for these two, for this value. Let us compare these two. Which is larger? 11 or 2? 11. So they will exchange themselves. 2 and 11. Which is greater? 13 or 11? 13. So there will be no shifting. Which is greater? 16, 13 or 6? Of course. What is the number? 16. 16 will come here, 13 will come here. That for pass 2, we have found the two highest elements at the rear, or at the top, you can say. They have bubbled up after the second pass. Now we'll not look for these two. 2, 11, which is greater? 11. So it has got correct position. 11, 6, which is greater? 11. So it will exchange. 11 will come here. So after only one exchange, 11, 12, 15 will have its position. Last, 2 and 6, which is greater? Of course, 6 is greater, so there will be no swap. The values will be in sorted order. This is bubble sort for you. Compare and contrast variable sorting technique with respect to memory space and computing time. So first of all, insertion sort, because of the nested loop, each of which can take n iterations, insertion sort is going to take order of n square. This bound is tight because it's asymptotic bound, big O notation, because input in reverse order can actually achieve this bound. So complexity will be n minus 1 by 2, that is again order of n square. Shell sort, the running time of shell sort depends on the choice of element, increment, which is increment in the sequence. So the worst case running time of shell sort using your shells, increment is order of n square only. Heap sort. The basic strategy is to build a heap of an element. This stage takes order of n time. Then we perform delete, because heap means the topmost element on the top. So delete operations of the element, leave the heap smallest first in sorted order. So by you can have min heap, so you can have smallest element here. So by recording these elements in the second array and then copying the array back, we sort n elements. Since the delete minimum will take, because order this heap is nothing but the binary tree, it will take log n time, but for this extra work, it will be n elements. So n log n will be the heap sort. Merge sort. Merge sort is a classic example of techniques used to analyze recursive routines, divide and conquer technique. So we'll assume say n is a power of 2, and so that we always split it into halves. So for n equal to 2, the time to merge sort is constant, which we will denote by 1. Otherwise, the time to merge sort n numbers is equal to the time to do with recursive merge sort of size n by 2 plus the time to merge. But this is the time to merge, and this is the time to divide. These are two halves. This is time to merge or sort the two halves, and this is time to merge. So the equation below says exactly what. T1 equal to 1, only one element, that is already sorted. If you have an element, it will be divided into two parts, and this will be 2 Tn by 2. So we have to recursively do Tn by 2, and then will be the effort taken to merge this. Then the quick sort, like merge sort, quick sort is recursive and it also use the divide and conquer. Such analysis requires solving a recurrence formula. So we'll do the analysis for the quick sort, assuming a random pivot, non-median of the 3 partitioning, and no cutoff for small files. So we will take T0, T1 equal to 1 as in merge sort. So the running time of quick sort is equal to the running time of the 2 recursive calls plus the linear time spent in the partition. So first is partition, then the recursive call to sort 2 parts. So the pivot selection takes only constant time, and this gives the basic quick sort as Tn is equal to Ti plus Tn minus 1, n minus I minus 1 plus n. And this will give order of n square only. What do you mean by hash clash? Explain in detail any one method to resolve hash collision. So hashing, as we have seen earlier also, hashing will have collision. So collision occurs when two different keys hash into the same hash value and are assigned to the same array element. So programmers have come up with various techniques for dealing with this conflict or collision. And the common way to deal with the collision is to create a linked list of entries that have same hash value. And for example, let the key of each entry hashes to the same hash value, and this result is both being assigned to the same array element on the hash table. So because two entries cannot be assigned to the same array element, the programmer creates a linked list. So the first user defined structure is assigned to the pointer in the array element. The second isn't assigned to any array element and is instead linked to the first user defined structure, thereby forming a linked list. For example, in a table size of say 7, 42 and 56 both will be 42 by 7, 56 by 7. Both will be both will want to take the they will be mapped to index 0. So it will be 42 and 57. How you are going to place 57? So you have to 25, 42. All these values can be mapped in which manner? So you can have 42, and if you want to place 56 also, so you can have 56, and then it can point to null. These are the value just by you can just divide it by or take modulo of 7. You are going to take the remainder modulo 7, and you can just place it like this. Describe the concept of binary search technique. Is it efficient than sequential search? So the binary search technique is a way of searching in which we divide first of all the sequence has to be sorted. So we take the middle value, search for it. Otherwise, depending upon whether the value in the middle is greater than the value to be searched, the algorithm takes the left or the right part. Binary technique is applied on an order list where elements are arranged either in ascending or descending order. So the array is divided into two parts. And the item being searched is compared with the item at the middle of the array. So if they are equal, the search is successful. Otherwise, the search is performed in either the first half or the second half of the array. And if the middle element is greater than the item being searched for, the search process is repeated and in the first half of the array. Otherwise, the process is repeated for the second half or the right one. Each time a comparison is made, the number of elements yet to be searched will be cut to half. Means half, 1 by 2, then 1 by 4, like this. So because of this division, the array into two equal parts, the method is called the binary search. Bi means 2. So the binary search, each iteration of loop halves the size of the list to be searched. So the maximum number of key comparisons will be 2 into log n, that is base 2. So this is quite an improvement over the sequential search, especially as the list gets larger. So the binary search, however, does not guarantee to be faster for searching the small list. You apply quick sort, it will give you a better result. Even though the binary search requires less number of comparison, each comparison requires more computation. So when n is small, the constant of proportionality may dominate. Therefore, in case of less number of elements in the list, the sequential search is adequate. Prove the hypothesis that a tree having m nodes has exactly m minus 1 edges or branches? Let us prove it. A tree having m nodes has exactly m minus 1 edges or branches. A root in a tree has in degree 0. It has no in degree, only out degree. And all other nodes have in degree 1. In degree 1. Okay, in degree 1. So there must be m minus 1 incoming arcs to the m minus 1 non-root nodes. So if there is any other arc, this arc must be terminated at any point of the node. So if the node is root, then its in degree will become 1. And this is the contradiction in the fact that root always have degree 0. So if the end point of this extra edge is any non-root node, then its in degree will be 2, which is again a contradiction. So there cannot be more arcs. Therefore, the tree with m vertices have exactly m minus 1 edges. What do you understand by tree traversal? Write a procedure for traversing a binary tree in pre-order and execute it on the following tree. Pre-order. Traversing means traveling through each node in certain way. So the algorithm walks through the data structure and performs some computation at each node in the tree. Some processing has been done while traveling or moving from one node to another. This process of walking through a tree is nothing but the tree traversal. So this is your tree traversal. So there are essentially two different methods in which to visit systematically all the nodes of the depth tree. First is your depth first, means you move from one position to another position and till the depth. Okay, means if you have taken say right or left subtree, you move to the last and then you cater other nodes after completing this. But in the breadth first this level, then this BC, then D, E, F, G, like this. So the tree depth first and breadth first are like this. Certain depth first traversal method occur frequently enough that they are given names like pre-order traversal, in-order traversal, and post-order traversal. So the algorithm of traveling a tree in pre-order, as we have been asked, is we have to process the root first. Always process the root and traverse to the left subtree of R again in the pre-order fashion, and traverse the right subtree R in the pre-order fashion. So we have to take root, then left, then right. Okay, this is the pre-order. So let us start how we can do. First we go to, if we start at A, when we start with A is what? A is root, so we write A. Then we go to L1 and then we go to R1. First we have to go to L1. In this L, when we reach here, we say that B is the root, so we take B. Then we go to this L11 and this L and this is R. So what we have to do? Root has been taken care, B, it has been written, so we have to take D and then E. So D and then E. So this is done. Now we come to the right subchild, right subtree. So as we reach here, C is the root of FG, so far we'll take C. And we go to the left, that is F, so we'll take F, and then right G. Left, right, so FG. This is the pre-order traversal of this tree. Write a procedure to insert a node into a linked list at a specific position and draw the same by taking an example. So this is the code. I hope you'll try it by yourself. And let me tell you how it exactly works, because if you understand this, then you can, if this concept is true to you, then only you are able to insert like this. So we have an element, say, of some time, and now you want to insert an element, insert a node into a linked list. So say you have position temp cell, and how you are going to do it, these are the 3 lines I'll tell you. First of all, a certain node where you want to insert, the pointer of this node which was pointing to this will now point to this. This is P next will point to what? This will point to the temp cell next, this one. And the temp cell will point to where? The P next. So this pointer will be pointing to the new node, and the new node pointer will be pointing to the next node. This is how we can insert. Define the adjacency matrix and make the same for the following undirected graph. This is an undirected graph. So adjacency matrix can be easily made. The representation consists of V cross V, where matrix A is the Aij, such that it will be 1 if Ij, if there is an edge from 1 to 2, or so say I to J, I to 0 otherwise. So we have say 1, 2, 3, 4, 5, 6 nodes, so 6 by 6 matrix will be made. And since 1 and 2 has path, we'll place it 1. 3 and 4 has path, we'll place 3 and 4 1, and likewise other will be kept as 0. So these are a few questions we have taken, and we'll be taking more on these shortly. Till then, thank you so much. Take care.